In this video, we're going to talk about another kind of sequence. Let's focus on our first example here. We have 2, 6, 18, 54, and a continuing sequence. To go from 2 to 6, and then from 6 to 18, and then from 18 to 54, we have to find a pattern, something that will allow us to continue this streak. In order to go from 2 to 6, we're just going to multiply by 3. To go from 6 to 18, once again, multiply by 3. To go from 18 to 54, once again, multiply by 3. So our pattern in this particular case is multiply by 3. Let's continue this pattern. 54 multiplied by 3. We continue times 3, and we continue times 3. 54 times 3 is going to give us 162. And 162 times 3 gives us 486. And that multiplied by 3 gives us 1,458. So now we have 1, 2, 3, 4, 5, 6, 7 terms. Let's take a look at the example below that. In this particular case, our numbers are not increasing like the first sequence. Instead, these numbers are decreasing. Now we're still talking about finding a pattern to go from one term to the next, just like we did with our arithmetic sequence. What pattern can we apply to make sure that we go from 64 to 32, and then from 32 to 16, and then from 16 to 8, and so on and so on? In this particular case, we're really going to divide by 2 each time. Which means the next term in our sequence would be 4, followed by 2, followed by 1. There's something interesting here. If we're talking about multiplication and division, we're really talking about what is known as a geometric sequence. This is a sequence in which a fixed number, which we're going to call a common ratio this time, is multiplied to the previous term to continue the series. Now the common ratio is the amount the previous term is multiplied by. This presents a problem for us, since in our second sequence, we don't talk about multiplication, we instead talk about division. So let's reflect on some of our previous knowledge. Dividing by 2. This can be expressed using multiplication. If you remember our rule for dividing by a fraction, we always would keep the first piece. So for example, the 64, we're dividing it by 2. Keep the first number, change division to multiplication, and flip the second number, which in this case means we are going to end up with a reciprocal. And the reciprocal of 2, we're starting with a fraction 2 over 1. So when you flip it over, it becomes 1/2. So really, instead of talking about dividing by 2, we can instead say that each time in this sequence, we are multiplying by 1/2. This does not change the result of the sequence. It just puts this into terms for us to call it a geometric sequence, and for this piece to become our common ratio. Now, if we apply this the same way that we did with our arithmetic sequence, n is once again representing our previous term. So if we start with our initial term of 64, what do we do to go from 64 to 32? Follow our pattern, which tells us take n and multiply it by 1/2. That would bring us to the next term. And we could do that following. Take 32, put that in place of n, multiply it by 1/2, and we have 16. So our rule, in this case, is the previous term multiplied by the common ratio of 1/2. Of course, this looks real awkward. So we're going to use all of our wonderful algebraic skills and restate this as an algebraic expression. So in this case, the rule 1/2 n will give us the resulting series of 64, 32, 16, 8, 4, 2, and 1, continuing on forever. Let's apply this to the first example. What is our common ratio? This time it's 3. And so if we were to set up our rule, once again, take your previous term, which is represented by n, and multiply it by your common ratio, which in this case is 3. If we put that into an algebraic expression in proper format, we now have 3n. Let's practice a little bit. Take the following sequences and find the remaining terms as well as the common ratio, and see if you can derive the rule. Pause your video while you do so. In this first example, as we continue through our sequence, we recognize that we are continuing to multiply by 5. So if we wish to continue the rest of this sequence, we'll continue to multiply by 5, giving us 3,125 for the next term, followed by 15,625, followed by another large number of 78,125. Which means in this case, our common ratio is 5. Therefore, if we're to create our rule, use our variable that represents the previous term, which is n, multiplied by the common ratio of 5, express it properly, and we have a rule of 5n. If we look at the second example, once again, we are looking for our common ratio. Now in this case, we have to think about what we can multiply 1,600 by to get 400. The simple answer would not involve multiplication at all. We would say divide by 4. However, that won't give us a common ratio. So once again, we have to think about what can we multiply by that would be the same as divided by 4. Multiplying by its reciprocal will give us the exact same response as dividing by 4, which means the actual pattern here, the common ratio, is multiplying by 1/4. So if we continue this, we'll end up with 5 as our next term, then 5/4, which is equal to 1 1/4 as our next piece. And finally, we'll end up with 5/16. If we wish to create a rule for this, it's once again the variable to represent your previous term, which was n, multiplied by our common ratio, express it properly, and we have 1/4 n. Let's take a look at this third example. By now you should be able to figure out that instead of using division, we are multiplying. So instead of dividing by 2 each time, we're multiplying by its reciprocal of 1/2. So if we continue through here, we're going to apply our common ratio of 1/2, leaving us with 1/4, 1/8, 1/16. Follow the same procedure. Our variable to represent the previous term multiplied by the common ratio, meaning we have a rule of 1/2 n. Pause your video and attempt the next one on your own. Okay, so if we're looking at these terms at the moment, we can see that we're starting with a fraction. And as we continue on, these fractions are actually getting larger and larger until we end up with a whole number. Let's focus on the denominators for a moment. 16 to 8 to 4 to 2. What's really happening here is we are taking a fraction of 1/16 and we are attempting to get it down to a fraction of 1/8. If we take this 1/8 and give it the same denominator, we are going to use the common factor here of 2 to make this 2/16. So we're going from 1/16 down to 2/16, or over to 2/16. What are we multiplying the original fraction by in order to move forward? In this case, we are multiplying by 2, which means our common ratio in this particular case is 2. So if we continue the pattern and extend our sequence, we'll have 2, 4, and then 8. If we multiply our variable to represent the previous term, which was n, by our common ratio, we have a rule of 2n. This video concludes our discussion on special kinds of sequences. If you need further review, please make sure that you see your teacher about this.